I see a dataset here with input values, x, and their corresponding predicted output values, y_pred, from a scikit-learn isotonic regression model. I'll use this data to evaluate the model's properties. This is the dataset I'll work with. The x values represent the input features, and y_pred shows the model's predictions for each. I'm analyzing an isotonic regression model, a type of regression that creates a non-decreasing relationship between input and output. It fits a line in a way that the slope never decreases. This is the multiple-choice question I'll be answering using the provided dataset and my knowledge of isotonic regression. This option asks if the model's output always increases, and the increase is always larger than the previous increase. I need to examine the y_pred values to check that. Here, I'll check if the model's predictions precisely match all the training data points. The convex function curves upward. I'll determine if this model always produces such a curve. This checks if the output values increase or at least stay the same as the input values increase. This is a core property of isotonic regression. I'll verify this in the y_pred values. This is the overall task. I'll interpret the results and evaluate the model's characteristics based on the question asked. I'm evaluating how well the isotonic regression model performs. This involves checking if the model's predictions align with its expected behavior. The dataset contains input values, x, and corresponding model predictions, y_pred. I use this data to assess the model's characteristics, like whether it's strictly increasing or simply non-decreasing. Let's dive in. This shows 5 data points. For each x value, there's a corresponding y_pred value representing the model's prediction. I analyze this data to determine the model's properties, specifically focusing on whether the y_pred values increase monotonically. I'm working with an isotonic regression model. This model finds the best possible fit to the data, while making sure the fit shows a non-decreasing trend. It is a type of regression that always increases or remains flat. The y_pred values are the outputs of the isotonic regression model. I'll be comparing these values to the input x values to assess if the model is monotonically increasing, perfectly fitting the data, or forming a convex function. It's all about understanding the patterns. I need to determine which statements about the model are correct based on the provided data. Let's see which statements hold true. I'm examining whether every successive y_pred value is strictly larger than the previous one. In simple terms, does the model always increase and never stays flat? I'm checking if the model's predictions match the actual values exactly. I'm seeing if the model's output forms a curve that always bends upwards, like a U-shape or a smile. I'm checking if the y_pred values never decrease as the x values increase. It just needs to stay the same or increase. This seems to be an incomplete entry and might be unrelated to the isotonic regression problem description. I'm not using this to make any analysis of the model. This shows the input values, x, and the corresponding predictions, y_pred, from the isotonic regression model. I see that as the input increases, so does the prediction, but not necessarily at a constant rate. I'm looking for a perfect match between the model's predictions and the actual training data. Isotonic regression doesn't guarantee this. It prioritizes a non-decreasing trend. Here, I'm asking if the predictions always increase by a larger amount each time. Nope, the increases are non-decreasing, but not strictly increasing. For example, the increase from 2.2 to 2.8 is less than the increase from 1.8 to 2.2. A convex function curves upwards. Isotonic regression doesn't ensure this. It only guarantees a non-decreasing trend. The model output might not always curve upwards. Yes, this is the key property of isotonic regression. As x increases, y_pred also increases or stays the same. It never decreases. The provided dataset contains input features, x, and their corresponding target values, implied in the y_pred values. This is the type of regression model used. It is characterized by finding a non-decreasing, piecewise linear relationship between the input and output. Think of it as finding the best fitting line that never goes down. Pretty cool, huh? This shows the input values, x, and the corresponding predicted values, y_pred, from the isotonic regression model. I see that as the input x increases, the predicted value y underscore pred also generally increases. This is the data I will use to check my understanding of isotonic regression. Let's dive in. These are multiple choice options. I need to determine which statements are true about the isotonic regression model and its output based on the provided data. Each option tests a specific property of the model. The key question is whether the relationship between input x and predicted output y underscore pred is non-decreasing. In simpler terms, does y underscore pred always increase or stay the same as x increases? This is what isotonic regression guarantees. I observe that this is indeed true. As x increases, y underscore pred either increases or stays the same. It never decreases. This confirms a key characteristic of isotonic regression. This is the dataset used to train and evaluate the isotonic regression model. I see a simple relationship between the features, x, and the target variable, implied by y underscore pred. This is the type of model used. Isotonic regression creates a non-decreasing piecewise linear fit to data. It fits the data by finding the best possible fit which does not decrease. This is the overall goal: to evaluate the performance and characteristics of the isotonic regression model using the given dataset. It involves examining the output and checking if it aligns with isotonic regression properties. I'm given a dataset with input values, x, equal to 1, 2, 3, 4, and 5. The corresponding predicted values, y underscore pred, from an isotonic regression model are 1.2, 1.8, 2.2, 2.8, and 3.5, respectively. This is the data I'll use to evaluate the model's properties. The model's output, y underscore pred, shows a sequence of predicted values. I'll examine these values to determine if they show certain characteristics, like strict monotonicity or convexity. The core question here is, do the model's predictions consistently increase or at least stay the same as the input values increase? We need to check if this non-decreasing relationship holds true. This is crucial for understanding if the model behaves as expected. These are the 4 options to assess. We will check each one. A strictly increasing function always goes up. A perfect fit means the model hits every data point exactly. A convex function curves upward. And finally, a non-decreasing function either goes up or stays flat. I'll evaluate each option against the model's output and determine if it's true or false. This is the core data. I will use this to check the properties of the model output. Note that x represents the input features, and y underscore pred represents the model's predictions. This shows the input data, x, and the corresponding model predictions, y underscore pred. I see that the input values are simply numbers 1 through 5. The predictions are also numbers, but I see they don't increase at a perfectly even rate. This is important because the question tests whether you understand isotonic regression's core characteristics. These are the predicted values that the isotonic regression model generated. You'll use this data to answer the questions about the model's properties. I see, the output values go up in a non-decreasing manner, which is key for isotonic regression. This is the collection of data that the model used for training. In this case, it is the simple set of pairs showing how the input, x, relates to output, y underscore pred. It's a small dataset but enough to test your understanding. This is the overall task. We're evaluating the results of an isotonic regression model to check if certain statements about its behavior are true or false. This is the type of machine learning model used. Isotonic regression produces a non-decreasing function. That is, the output values never decrease as the input values increase. This is the main question you will answer using the given data and your understanding of isotonic regression. This statement asks if the model always creates a convex function, a function where a line segment between any 2 points on the graph lies above the graph. Isotonic regression doesn't guarantee convexity. It only guarantees a non-decreasing relationship between input and output. This is asking if isotonic regression always perfectly predicts the training data. Nope. Isotonic regression aims for the best non-decreasing fit, but it's not always a perfect match. This statement checks if the model's predictions, y underscore pred, consistently increase or stay the same as the input values, x, increase. This is true. The y_pred values show a non-decreasing pattern. This asks if the model's output values always increase by a strict amount. Strictly increasing means that every successive value must be greater than the one before. This is not guaranteed by isotonic regression. It only guarantees a non-decreasing relationship. This shows the input data x and the corresponding model predictions ypred. I'll use this data to check if the statements about the model are true. Notice that the x values increase steadily, while the predicted values ypred also generally increase, but not at a perfectly consistent rate. That's key to understanding this isotonic regression model. This is the core question. I need to evaluate each statement using the provided data and my understanding of isotonic regression. It's a multiple-choice question testing comprehension of isotonic regression properties. Let's dive in. The ypred values are the predictions from the isotonic regression model. I'll focus on how these values change as the x values change to evaluate the different claims about the model. This refers to the data I'm working with, the x and ypred values. The dataset is small, but it's enough to understand the key characteristics of the isotonic regression. This is the overarching goal. I need to assess the model's properties using the given data. I'm checking how well the model fits the data and whether it follows the expected properties of an isotonic regression model. This specifies the type of model that is used, isotonic regression. I need to remember the theoretical properties of this model type.